Look at the day that rocked the world. So make sure you look at the calendar there, and in particular the year. What it gives you is October the 4th, 1957. And what rocked the world? There was a rocket launch in the Soviet Union. And what was going to be special about that rocket launch, because there had been liquid fuel rockets since Robert Goddard's first in 1926. What made this one so special? The rocket contained a payload of the first ever artificial satellite. It was housed in the nose cone at the top of the R7 rocket. And you've got a picture there of the launch, the satellite in the nose cone, and the location of the launch in Baikonur Cosmodrome in what is now Kazakhstan, but then was in the Soviet Union. And it was given the name by the Soviets, the Artificial Earth Satellite. If you read the translation of the Russian text, it's got Sputnik in it, and so in the West it just became known as Sputnik rather than all those words which mean Artificial Earth Satellite. But other names, PS1, Simple Travelling Companion. Sputnik translates into Travelling Companion, and you might like to see the Cyrillic script of Sputnik. And Sputnik was actually designed to be noticed. Its orbit, its radio transmission, its design. And here the orbit covered most of the world's populated landmass, so vast majority of people would not necessarily be able to see it, but hear of it, and the country's news stations would broadcast, etc. The radio transmission and could be picked up by amateur radio enthusiasts. So it just wasn't reliant on a government agency or the military. It was people in your neighborhood, maybe. And its design, it was shiny and with sunlight shining on it, just visible in a dark night sky with little light pollution. And so Sputnik's orbit, a little more about that. It wasn't just a single orbit as shown here at the launch site. In fact, the ellipse orbit wouldn't join up there. It would spiral round 1,200 miles to the west each time. So it would cover a lot of the world. 1,440 orbits, 92 days, 70 million kilometers, each orbit taking just over an hour and a half. And you look at the diagram there and you see how far up in the Earth's atmosphere, the range of the orbit range, and eventually the orbit would decay and Sputnik would be lost as it burned up in the atmosphere. And so we start off on the left-hand side with Sputnik animation being released from the rocket. And as soon as it was released, there was a pin control where it started emitting the radio signals. Now, what are radio signals? Look at the top strip in the middle with the red box around it. The whole of that strip with the coloured ones in the middle is the electromagnetic spectrum. The coloured ones are visible region, and the box on the right, radio waves, which are the longest wavelengths. And you've got a picture of the wavelengths behind as well. And the Sputnik was emitting a beep every 0.4 seconds on frequencies of 20 megahertz and 40 megahertz. And those are able to be picked up by amateur radio enthusiasts, and also they will come through the Earth's atmosphere. And the diagram at the bottom got someone with binoculars in the middle, and to their right, shorter wavelengths as the satellite was coming towards you with the Doppler shift. You get shorter wavelengths with a higher pitch. As it goes past, you get longer wavelengths and a lower pitch. And this is like an ambulance siren, which you may have experienced. And here we're looking at the Earth with the atmospheric barrier, the dotted line, way further out from the surface than in reality at that scale. It would barely be another just thin line above the Earth's surface. And you've got gamma rays through radio waves, your electromagnetic spectrum, and only visible and radio waves can reach the Earth's surface through the atmosphere. So any of the others, you're going to need a space X-ray for to be able to see and determine gamma rays, X-rays, ultraviolet, infrared, microwaves. And what did Sputnik discover? Density of the upper atmosphere by investigating Sputnik's orbital decay rate, the effect of the ionosphere on radio signals. So you're listening to that message very carefully, you're looking at its location. Sputnik was designed to be noticed, so its design, barely large enough to be seen crossing the sky. The rocket with it could be seen more easily of one of the stages, but it was shiny, spherical to have less resistance, and the outer layer was a shiny heat shield and a 2 millimeter aluminum alloy. And if you want to remind yourself how shiny it might have been, look at some aluminum foil and pause to read about alloys. And what had happened after Sputnik had been launched and had reached the press, as there are 2 articles here that you can follow up on, New York Times and the Russian Pravda, both for October 5th. And then military and scientific advances, changes, whatever. They say that America was actually shocked, I put surprised here, that actually a satellite had been launched. And it led to the creation of DARPA, originally back then, the Advanced Research Project Agency, and of NASA. There was NACA before it, but it was given more money, jump-started. And post-Sputnik research led to development of satellite navigation with the US Navy transit satellite system for ships and submarines. And in terms of education, National Defense Education Act, September the 2nd, 1958, under a year after the launch of Sputnik, modern math, hands-on activities in math and in science to engage students and promote science. There's also popular culture. There's a couple of things. One's a music box, one's a pin. The Sputnik pin that is there was actually owned by an astronaut, David Brown. And a little bit more about Sputnik. You've got an expanded satellite capsule here, 2 hemispheres that were joined together with 36 bolts and various little rings, gaskets, to get an airtight seal. And inside the almost octagonal sandwich box in the middle, there are 3 silver zinc batteries, 2 of which were to produce the radio transmission, and a cooling fan. And if the temperature went too high or too low, the signal actually changed. I got a picture of Korolev, Russian rocket and space pioneer designer, and then a scale there just to show you Sputnik, and I happened to put a kudu there just because the mass was about right, but equally a person, 184-pound person, would weigh the same as Sputnik. And the photograph at the top right is contemporary in 1957 of preparing Sputnik. And what we can actually do is make a life-size model. Here it is. That's actually for the 50th anniversary. And you can pause to get materials that are here. You can pause here with partway through with the procedure, and then painting to make it look a little bit more authentic. Do it outside, still cover with newsprint, and make sure your eyes are well protected from paint. And then to actually present it, have an adult do that, please, with the correct step ladders, and please use care. And you can pause the video here to follow any, or indeed all, but any of these about what happened with after Sputnik, and some interesting articles, and the PhD thesis there is really quite readable, or parts of it as much as you want to. And so these are the beeps that changed the world, and Sputnik, which was at the dawn of the space age.